Okay, hello and welcome to another episode of the DevRel Book Club. I'm Matthew Ravel and I'm joined, as always, by...
Hello, I'm Ramon Huidobro. It's good to see you all. Hope everybody's having a wonderful day. And yeah, so good to do another episode.
Yeah, how are you, Ramon? Are you good?
All fine here, thank you. I'm having a very solid start to the year, settling into the new things I'm doing, trying out some new things. I'm excited. I'm excited. How about you, Matthew?
Yeah, well, very similar. I am on the verge, and maybe by the time this goes out, it will have happened, but of announcing a whole new series of DevRel content that we're doing at developerrelations.com. And thank you very much to Common Room for sponsoring this episode. You can go to commonroom.io if you want to learn more about their platform for helping you to understand and measure your community. So lots of really exciting things about to happen. And talking of exciting things, we have a first for the DevRel Book Club, which is a returning guest.
Yes, it is my esteemed joy to welcome back our guest from our very first episode, Joe Nash. Hey, Joe, how are you?
Hello. Thank you so much for having me back. I'm doing great, thanks. How are you two?
Yeah, good stuff, yeah. It's so that first one that we did, which you mentioned earlier, was January last year. So yeah, we've been doing this a year, Ramon, which is remarkable news to me. I didn't realize it had been going that long.
No, it's amazing. Thank you.
But when we first did that one, I don't think I have the book here. It's probably on a shelf somewhere else. But we covered quite an academic text, which was MIT Press's, is it called Building or Designing?
Building Successful Online Communities, a research-backed approach. Is that the subtitle? Something
Evidence-based social design.
There we go.
Look at Ramon. He's ready to go. But that was an academic text which had lots of relevance to what we do in developer relations. And we're going for a similar approach this time. Joe, you have brought us the Cambridge Handbook of Computer Education Research, which...
A chonky boy.
Yeah.
All 901 pages of it.
So, Joe, we've got to ask, why this book in particular?
Why do I keep doing this to you? My new January rhythm is bringing oppressively academic texts to your poor book club. Why this book in particular? So I think we spoke about it on the first episode with the Building Successful Online Communities books, which is one of the things I found really useful about that book was there is a bunch of stuff that we are taught or we learn as DevRel practitioners that to some extent we take for granted, right? Like we're told them by people senior to us or by DevRel Talks, etc. That like this works and this is this is the way we do things. And some of that is backed up by things people have seen in their roles, but that community book, what it was really interesting about it for me was like it had studies and citations galore from the scientific literature that it clearly explained the things we were seeing as professionals. And that was really exciting to me. I really loved having that evidence, that data. And this book is very much ticks those same boxes, but about a whole heap of other areas of our work. So it covers teaching computing concepts in general, but from all different angles. So, there's a whole chapter dedicated to the challenges of teaching novice programmers how to code and the reasons, from all kinds of different angles, not just in terms of teaching techniques, but also what's happening in the brain and, what's happening socially in the classroom and all these different factors that lead to students struggling on their coding journey. And it's a really broad book, and we'll talk about its nature as a handbook and who it's for, I'm sure. But it's a very broad text that touches on lots of different areas and points you to the scientific literature in a way that you can start to explore that world and bring it into your professional DevRel life.
Thank you. Yeah, no, I was super excited when we got to read this book because very similarly to the MIT book that we explored in episode 1, for me, reading the parts of this book that I read, because I will admit, and we'll talk about this in a moment, that I didn't read all of it. What I found so fascinating is this concept that I've been discovering with reading literature in relation to communities and computer science education, or teaching computing in general, is that it puts a lot of and I have to be very careful that I get this right, words to thoughts.
Yes.
It gives a lot. Yeah. So it explains these things that I've been sort of taking for granted. For context, I started out early in my career by teaching children to code, which was for me a very, very meaningful experience.
Right.
Actually, it's been long enough now that some of them are, working in game development, which is just incredible.
Yeah.
But also that got me curious when it came to time to write my bachelor thesis to think about, okay, how does this apply to the science of learning and teaching? And it was really cool to see concepts from that research I did come up here. Concepts like constructionism, and the cognitive sciences. But of course, as I said, I didn't read all of it, and when those of us who are not even though I mentioned that I did some research, I wouldn't consider myself an academic. I'm wondering, how do you recommend approaching this book for someone who's curious but overwhelmed, perhaps?
So I think I have kind of two different strains of advice, one about academic texts in general, and then one in particular to this book, and actually even this series of books, the Cambridge Handbooks. So academic texts in general, I think a lot of folks, especially if you're reading kind of like business books, right, like business nonfiction, are used to books that are, kind of meant to be read front to back by a single author. They are laying out a set of ideas and kind of a linear narrative, and they are, not to be inflammatory, but quite information, like they're not very dense information, right? Like you can often listen to them at like 3 times speed, and cliff notes are really useful for that kind of book. With academic texts, it's a very different approach, and I think one of the things people struggle with when they first start reading academic texts, and one of the reasons why people struggle with them, is this feeling that I'm reading this front to back is really unpleasant. I must be bad at reading, and no, they're not meant to be read like that. When you, I've recently started doing graduate study again. And one of the things we're being taught is in terms of reading academic texts is a different mode of reading. You first of all do a surface skim to check for the relevance and check for hey, what is this paper trying to convey? What's the key ideas? And then you skip the bulk of the paper and go to the conclusion and see what they actually found. And then if that information is useful to you, if that information is relevant to you, you can then start to go deeper and start to look at the method and these kind of things. And this book is very similar. So that is the approach you should take this book, similar to an academic paper, because the way this book is organized, it's not one text by one author laying out a linear series of ideas. It's a bunch of chapters contributed by different groups of researchers in the style of academic articles. So each chapter, you can kind of think of it as an individual paper. And so they all stand on their own. Some of them refer to each other, but they all stand on their own because it is a handbook. It is a manual. It's not meant to be read front to back. It's meant to be kind of like a troubleshooting guide. Hey, I am interested in computing education research and I am thinking about it, and I have encountered this problem, or I've encountered this concept I'm unfamiliar with. Let me crack open my handbook and go to the relevant chapter and dig in and try and find information on that. So very much not a book you read front to cover. As you said, Ramon, you haven't read all of it. I have had this book for a while and have found uses for a lot of it, but there are parts of it that I have not read either because I haven't needed them in my work or research yet. And yeah, definitely pick and mix from this book for sure.
So one word that comes up a lot is pedagogy. And I wonder if you could help us non-education experts to really understand what pedagogy means in the context of what we do as DevRel people, developer educators.
Yeah, for sure. So I will say this is exactly the sort of stuff that I bought this book for. So, as a DevRel practitioner, and a lot of my job involves educating developers on how to use given technologies. And so I kind of had the feeling that I was doing all of these things and I was kind of making up as I go along and, doing workshops and tutorials. And I was like, wait a minute, but teaching exists and there's a degree in teaching, so surely there is science for this. And trying to find that information, and particularly pedagogy, I'm so glad you started with this, because hearing that word a lot was the one that made me go where do I learn these words? And this is why I picked up this book. This is, the thing that brought me to this book. And so pedagogy in particular is the ped in pedagogy is referring to teaching children. It is the practice of teaching children, and it is the methods of instruction that you use. So the actual way you teach children. And that straight away is more or less relevant to our work. Not all of us are teaching children. Even when you're teaching adults, which is andragogy, you tend to still talk about your pedagogy, and your pedagogy is kind of the manner in which you teach, the tactics that you use to teach. There are lots of different foundational theories around how we learn that influence. So, Ramon, you mentioned constructivism and also constructionism, two different things. These are different foundational theories about how people learn, how knowledge is built in the brain, that influence your pedagogy. So, for example, a resource that I really love a lot is Raspberry Pi's pedagogy quick cheat sheets, quick reads, I think they're called. And these are literally one pages that explain popular research-backed teaching techniques. And one of the really popular ones that they cover, which comes up in this book as well, is called a Parsons problem, which is where you have a complete block of code and you scramble it. So you put the lines out of order, and then the task for the learner is to order the lines of code so that the code works. And this approach, this pedagogy, is based in one of the lines of thinking around like one of the foundational learning theories, which is cognitive load theory, which is that like the amount that you're trying to, you have short-term memory, long-term memory, your brain can only process so much information at once. And when you're learning to program, you've got syntax, you've got semantics, you've got lots of different things. So Parsons problems remove the syntax. We're not learning to type correct code. We're just learning about the structure of code. And so that's a pedagogy based in one of these foundations. And so these are the kind of things like when you're coming to your workshop and you're thinking, I'm going to have a demo here, I'm going to have an exercise here. In this exercise, they'll be doing X, Y, Z for this. What you're doing is choosing you're designing your pedagogy. And so that's kind of, what fundamentally what, we as educators are doing. And this book kind of lifts the covers on a lot of the decisions we make and puts, as you said, Ramon, like words to like explains a lot of that, and will help explain your preferences and help you explore your preferences and your beliefs around what is effective teaching.
Thank you. Yeah, it's something that I experienced as well, and I wanted to dive in a little bit, if I may. Very like in chapter 8, one part that very much stood out to me was the sort of relationship differentiation at adjacent nature of the learning sciences and computing education. In particular, the book talked about something that really resonated with me was, for example, I'm going to quote the book, if I may, on page 208. For example, a computer scientist might build educational software based on a sequence of concepts that need to be learned. If the computer scientist was also a learning scientist, they would design the learning experience about how these concepts connect to the existing cognitive architecture that the learner has and the identity, motivations, and experiences of the learner. And what this really said to me was sort of, if I were to think to the sort of most fundamental computing education step, or one of the beginning ones, is the Hello World program, right? What can you tell us about I'd love to hear what your experiences are between these two.
Yeah. I think, so I guess like a key thing to touch on here is like bridging the gap between, computer scientists and learning researchers is very much the aim of the book. So, the book is aimed at two groups of people, kind of distinct, which is like computer scientists who are interested in the learning scientists and learning scientists who are interested in computer education. And so chapter 8, the learning sciences for computing education chapter, is the chapter literally made me want to buy this book, is the chapter that says like, hey, you are a, computer science person, here is what you need to know about how learning works. And so I think that's very like, that's the context, exactly that, like this is the exact context which I came to it. The example you gave is the exact context to which I came to this, where it's like, I have been doing lots of workshops and talks my whole career, and I've observed things that work and observed things that didn't. And I wanted to know why that was the case. I wanted to know like, hey, we start with Hello World, and like, that's a minimal example. Is that the only reason we start with Hello World? Like, is there more to it? And actually, funnily enough, like another place that I think, this is not in this book, but is in a paper by a researcher called Felina Hermans that I was reading today for other reasons. But like, there is so much we can learn about our jobs from the adjacent like fields of psychology and cognitive science that are covered in this book. And like a really key insight from this paper today that's almost like mentioned offhand is like is talking about the link between learning programming and learning natural language, so learning spoken languages, English, German, whatever, and talking about how children acquire language, and in particular how children acquire punctuation, and the finding that one of the last things that children acquire in natural language is the parenthesis and the colon, which are fundamental pieces of syntax in most programming languages. And you know what language doesn't rely on parentheses and colons very often? Python. Do you know what language is most popular in teaching kids? Python. And that's like, there you go. That's why, like, a concept that's really difficult to them because they just haven't acquired it in natural language yet. And we've just like I always thought Python's an easier language. Why is Python easier? Well, it's simple, whatever. But like I wouldn't have made that connection, right? And so it's that kind of stuff that's really interesting to me, that kind of stuff that, this chapter and the example you gave, those kind of connections that it makes. And the ones with, cognitive science as well, I also think are super important. Like this book has a whole chapter on it. It's chapter 9. There's also another great book, again, by Feline Hermans, which we've spoken about for this podcast before, or I'd spoken about doing for this podcast. I don't think we've done it yet, which is called The Programmer's Brain. But like another thing, like a whole section of stuff that's really interesting here is just like, you have different forms of memory. Sure, it's also on my shelf somewhere. You have like short-term and long-term and working, and there's different types of long-term memory, and the way things are encoded in your brain is very different. Like the ways you can recall things is very different. And you are using all those types of memory when you program, but also when you learn. And we don't often like when you read that, you'll instantly recognize patterns in where people have struggled with concepts in your workshops, where your documentation overloads people. Yeah, I don't know if I answered the question entirely. I got very excited by it, so kind of ran off into the woods. But yeah,
I mean that's what we're here for, and I think I think that's what this book does really well. It's sort of giving us those, as I keep saying, words for those thoughts, where we connect these things. One particular one that stood out to me was the concept of the chapter 8 spends a section on productive failure, right? Which for me is something that I've been experiencing so much, especially in the last couple of years in my work, of giving folks the opportunity to use failure as a teaching tool. We say that very informally. Learn from your mistakes. Making mistakes is the most common thing we can do, and it's good for us. But having that scientific backing to it, the fact that this is sort of built into design. I remember when we were making games with the kids, I would allow them to put as many enemies on screen as they like. Tell them, like, I don't know, 10, 15 enemies on screen. And they would just, mash that number 9 until their computers froze. And that's when they had an understanding of, for example, how much computing power goes into,
right,
a game working.
They get the mental model of what's happening in the machine, right? Like in a way that you couldn't intentionally teach. And I think that's this chapter in particular, and I think I said this to you before in the Slack, this chapter in particular is kind of like, if you think about, like, if listeners think to this, like reading this, like if you take a moment now to jot down on the piece of paper just like your top thoughts about like what is good to do in a tutorial, or what is good to do in a demo, or what is good to do in a documentation portal or a workshop, and then you read this chapter, you will tick those. You will be like, oh, that's why that's good. That's why that's good. So, we do worked examples. We provide example code and let people play with it. We have sandboxes in our documentation portals. It's constructivism. Constructivism is letting people build their knowledge via taking what they already know and playing with it and expanding it and applying what they know to new problem domains, and like basically not direct teaching, not being told what to do, but exploring. That's what we do when, we let people do, we have API explorers, and we have the idea of like making their first request and letting them get on with it, that kind of stuff. Cognitive apprenticeship is another one in here that's really interesting, which is the idea that throughout history, training, lots of, like the way we've kind of trained people in lots of trades is via apprenticeship, master to student, small class sizes, like a single apprentice, single master kind of thing, real SIF setup. And that doesn't scale to classrooms, but there are parts of that we that we can take and do scale. So one of the things masters do is they model their expertise. And again, we do that. We go on stage and we do live coding demos. We model how to solve a problem. We're doing cognitive apprenticeship. And then, productive failure is another one where especially in, I feel like the last couple of years of live stream content, one of the most compelling formats, I think, for live coders is just messing up on screen and then working your way out of it. And, when we talk about demos and live coding things, one of the earliest principles I was taught around doing live coding demos is hey, make a mistake and show your debugging process and show how to get out of it, or encounter an error and come out of it. And there's literally every single thing I know about communicating technical information is one of these theories, which is so exciting.
And it's good and exciting to know why the things that you already do work and make sense. But have you been able to then build on some of these things because you understand what's underneath it in order to create new techniques or approaches in your work?
Yeah, absolutely. So I think one thing, one of the kind of areas of understanding these different theories is also kind of understanding where these theories are not opposed, but these theories are all accepted. They all exist. Different researchers have different opinions on them. There's different, favorites. For example, me and Ramon were talking before the show. Chapter 8 is talking about constructivism, and the author of Chapter 8 is a fan of constructivism, and the author of Chapter 10 at one point calls it non-scientific. And there's a remark in Chapter 8 where they're the authors of Chapter 10 don't think this is scientific, but we disagree, which I just love as a textual thing. So, but what they do a really good job of quite frequently is putting these techniques on a spectrum of understanding, but also kind of use cases and where they fit. So constructivism, behaviorism, for example, right? One of the things that this book gets into is constructivism, having people explore stuff yes, that's really powerful, but people will often not learn what you intended them to learn, because if they're exploring by themselves, they might learn something, but you don't necessarily know what they're learning, right? Again, Ramon, your example there of adding loads of characters to the screen, they learn that their program breaks, but do they connect the dots and know exactly why that is? They probably need some guidance. They need some direct instruction to know why that is. And then you get to behaviorism. And so knowing kind of the limitations of each technique and why there are those limitations is one of the things that knowing the underlying theories is really helpful for. So another example is learning objectives. Learning objectives, learning outcomes, starting your content with, by the end of this workshop, you will know XYZ. That's very behaviorist. And that's very, behaviorism is very, does a lot of direct instruction. So literally telling someone, this function does this, rather than saying, hey, run this function. What do you think happens? And there's a lot of interplay, especially in coding, and a lot of research in coding that says that coders are more effective if they see, for example, if you're learning how to build a web application, if you put someone in front of a blank editor and you say, build a web application, do a constructivism, they will really struggle to do it. But if they see someone build it first and then are told to do it, they're much better. And that's intuitive. That makes sense. We understand that as people who have engaged with learning. We understand that's the way, that's the way to do it. But the theories really let you explore that space and know exactly when to make a leap off to something else. Why you might be seeing the results you are in the classroom. I can bang out a curriculum for a workshop and then run that and see certain things happening and be able to reason about oh, that's why this is happening. I should apply this technique here instead, right? So I don't know if I wouldn't say I'm doing anything novel. I wouldn't say this is leapt off for me to find new learning stuff, but it's definitely, again, allowed me to approach content development in a more rigorous way and know exactly why, be able to anticipate the outcome a lot better. And when it doesn't work how I want, I'm able to reason a lot more effectively about why it hasn't worked out how I want, right? I feel like for a lot of my career, especially for online courses, I've kind of just relied on hey, this percentage of students finish the course, and that's kind of industry norm. The one I always quote all the time is the peak industry norm is every one of us knows that 30% of a 30% open rate on an email campaign is really good. I don't know why anyone knows that, but we all know that, right? And so that's kind of the same with online courses, where it's 15% finishing your online course, that's really good. And this background has allowed me to kind of like plug into that and go like, hey, this is the rate I'm getting. Oh, now I know why that's good. Now I can see why these folks have dropped off, etc.
You took us through how understanding these theories can help you to identify or understand why certain things have happened in your developer education practice. But how can we take the learnings from this book and the theories here and actually put them into intentionally designed DevRel programs and developer education programs using them? But also I've got a note here that says, isn't it time for us to get serious about developer education as a discipline in its own right?
Yeah, for sure. So I guess we'll start with that last bit. I definitely think, it's not my first time on this podcast, but also I imagine most journalists, it's not the first time listening to me talk about DevRel. There's a lot of areas of DevRel where I think we not wing it, but like where we have kind of reinvented things from first principles, and that's the only knowledge we're willing to explore. And developer education is definitely one of them. Like, I think the way we do workshops, the way we do tutorials, the way we learn to do workshops, the way we learn to do tutorials is all like knowledge from within the DevRel field. And, sometimes we're very fortunate and people come into the DevRel field from an education background and kind of bring new stuff with them and help widen our horizons. But I do think, and I gave a DevRelCon talk about this in 2019, actually, that we really should stop just doing that wheel reinventing and just like accept that we're educators and there is best practice for educators, and actually we should be engaging with that before we start. My DevRelCon 2019 talk, for example, was about a researcher, Ada Kim, who had looked at all of like the online coding tutorial platforms like Treehouse and Codecademy and Microsoft Learn, and had basically rated them on their like pedagogic approach and the validity of that, and found a lot of them very wanting. And that doesn't need to be that way, because there's a lot of body of science about this. Computer science education itself is, especially for younger folks, is still in early stages. It's iterating rapidly. There's a lot of, lots of countries have brought in new curriculums, and it's been more or less successful for various reasons. And so it's not a perfected science by any means, but there's still a lot of stuff there that, we should definitely be drawing on. So in terms of drawing on that, I think the easiest way to do it is, without understanding any of the foundations, without getting really deep into learning sciences, have a look at some of the pedagogic approach, I don't know if that's the correct word, pedagogy that teachers are using in classrooms, bearing in mind again that these are for kids, and so they will need adapting for your work. But just think about why are these the techniques they're using, and do they apply to me? So again, a really great resource for this is Raspberry Pi's Pedagogy Quick Reads. And one in particular that I think is just universally applicable to like everyone teaching coding concepts is the semantic wave, which is one of the pedagogies of like, you're introducing a new word, a new term, a new concept. What is the process that people go through the semantic wave between like understanding the meaning and the semantics of that word and incorporating it into their knowledge? And that is like, we all introduce new concepts of our technology, whether we're doing like, whether we're advocating for a library in a programming language as probably a concept, or your company's got a completely novel API or something like that, there will be new concepts. And so the semantic wave is universally applicable, and is a technique that you can use to structure your content immediately. You just pick up that sheet and you go. And there's loads of like things like that. Well, they're not, some of them are addressed in this. So Parsons Problems is addressed in this book, and you could probably implement Parsons Problems from the recommendations in this book. But just as a blunt instrument to get started, the Raspberry Pi Pedagogy Quick Reads, you will find something useful in there for sure.
Thank you. Yeah, that's really good to know as well. And I think what you touched upon there, especially, and also in your talk from 2019, which I'm going to have to go watch, because that sounds like something I'd like to very much get a lot of use out of. So thank you for that. Something that this book touches upon that I've been thinking a lot about recently as well is this concept of, teaching concepts, especially to novice programmers, to emerging developers, people who are getting started. And one thing the book mentions in chapter 12 that really stood out to me is this sort of lack of a agreed upon list of topics that need to go into an introduction to computer science. Yeah. Which, I mean, that's a knowing chuckle. Like I think a lot of us have been there of thinking like, what, how do we do this? I'm curious. How does, reading this section on making content accessible to novice programmers, and when I mean accessible, I don't just mean in the approachable sense, but also accessible really in every sense of the word. How has this affected the way you approach teaching concepts?
Yeah, this chapter in particular has been very useful for me. So, and this is something that's probably quite unique about my role and career versus some other DevRel folks. But like I tend to focus on early in career developers in my roles. So my roles historically have been, like folks who are new graduates or bootcamp students or whatever, and helping them become the kind of developer who would use a company's technology, right? So I run into this program all the time, and in particular with so my day job at the moment is working on a game called Twilio Quest, which is Twilio's free coding game, and that game, was started out as a fun way to learn Twilio, and along the way, it being a game, it has attracted lots of newer programmers, lots of younger programmers, and we've just discovered like the incredible gulf between like what even a couple of years into the industry, like what to be able to interact with an API like Twilio, and what someone fresh like to programming knows about a computer and the difference between them. Like it's like some really common, I guess, like things that like I encounter daily is like we spoke a little bit about students learning that a computer can crash, but like just understanding like having a mental model of what a computer is and how it works is not intuitive. Like people don't, and that might be taught, might not. Like my computer science degree, we started programming in ARM assembly, like assembly language, and that doesn't, lots of people will look at a computer science degree and say, well, that doesn't set you up with the skills needed for a job. You need to be learning JavaScript. And like, yeah, sure, I like can't go get a job writing assembly. I could go get a job writing assembly, but I'm probably not going to get a job writing assembly. But what that did teach me is how memory worked, how a computer works. And like, it gave me an incredible mental model of how the computer actually functions that like allowed, and we were talking about how exciting transfer is. One of the foundational learning concepts is out of transfer, being able to apply what to other structures, other domains. I was able to transfer that knowledge to when I encountered more dynamic languages. When you get into JavaScript and Ruby, you learn about the difference between the stack and the heap and where data is stored and how variables are accessed, and shallow copying versus deep copying. That all just intuitively makes sense if you know how the computer works. But if you don't know how the computer works and you are defining an object in JavaScript and you're assigning it to a variable and then you're editing the original object, what the hell happens there and why does it happen? You have no idea, right? Absolutely no idea. And you can't be taught that without being taught how the computer works. And so these are the kind of things that like when people say things like, oh, computer science doesn't teach like what industry needs, A, I get very wound up because they don't know what they're talking about. But B, this is the kind of just like already in that incredibly simple example on this podcast in 10 minutes, the gulf of complexity in teaching people how to program, right? Because we're not just teaching them how to program, we're teaching them how to problem solve, we're teaching them how to reason, we're teaching them how to read, like we're teaching them a new language. Like there's lots of similarities with natural languages. You're teaching them how to respond to a feedback system. Like no one knows how to interact with error messages when they first encounter them, or how to understand them. Like there's so much there. And again, like a lot of that I'd observed just from my work and had started to kind of put into my content. But then like this novice programmers chapter 12, like breaks down the cognitive processes that are happening in a novice's programmer's head. Like it talks about, like it correlates different failure rates seen in schools with like, why that might be happening and the different structures of courses. And they analyzed courses in aggregate. There's a paper, I don't think it's cited in this one, but it's another paper that looked at like, in America, they have very uniform course names for computer science. So like CS1 is always the first module. And this paper found that like there's basically no consistency between what's in a CS1. So all these courses called the same, but you have no idea what someone has learned from CS1. And this book points out that like of CS1 students, like less than 38, I think it was 38% was the figure, something around that can't write a basic for loop that works out an average of an array. But they're learning something, right? Like it's so fascinating. And I think it's just that complexity that like we talk a lot in DevRel and in content about like the curse of knowledge, about like once you've learned something, it's difficult to teach someone it because like you no longer have that viewpoint, that empathy of knowing what it's like to not understand that. And like this chapter alone points out the so many ways that is true, and why it's true.
I think one concept that you know in my experience of you know learning, for context, I still don't have my bachelor's degree in computer science, in software engineering rather, and one that I keep seeing be hopped over is that of logic, of understanding how a computer operates. Have you ever seen that video of that teacher teaching their students how a computer makes a sandwich?
No. Oh wait, yes. Hang on. I have with his kids. He asks them to write out the steps to make a peanut butter sandwich, and then he follows it literally like a computer would, right? And he ends up like doing crazy things, like you know, just putting butter on the counter and that kind of stuff. That one.
Yes, exactly. Yeah. And I think there was a game that came out of a push for better computer science education in the United States called Lightbot. Mm-hmm. Which I really liked, which was, you know, a game where you programmed a robot with drag and drop instructions. Yeah. And I feel like taking those approaches to the things we do, and it's something the book covers as well, is like, what are the different kinds of educational platforms, I suppose, or what are the kinds of things we do? And one that I think is one that they mention, and that is also very relevant, is that of, for example, social media, which is something we're seeing quite an explosion of, especially in the last 3 years of short video format educational content. And I think taking a step back to you know, process those and give that pedagogical context to what we're teaching and how we learn, and addressing something that addressing these new concepts in a way that makes sense is something we still need to continue doing.
Yeah, and this is one of my favorite things. I guess like I just love to be the guy that asks why all the time, and like content formats is one of the things that drives me up the wall in this regard, right? Like cool, short videos are trendy now. TikTok's a thing. We know people's attention span is low. Let's do all of our educational content in short form video. It's kind of like why? Like what is the pedagogy approach there? Like how are you teaching them? How does that video convey the knowledge? Like what is the difference? Why do they engage a bit better than the long form content? And I don't think we often, especially in DevRel, conflate the tactical with the strategic, right? Like we will say, how do I do this thing? And instead of, you know, instead of asking about the higher strategic aims, we get very caught in the precise details, and like we don't actually really know why we're using that tactic in the first place. We haven't, you know, addressed the strategy. And I think that happens a lot in developer content. You know, like the docs framework, the Divio docs framework that most people follow is very, very good. And I think it's, you know, broadly accurate. And I think this book validates it in a lot of ways. But like, you know, if you're going to go write some new documentation, there's kind of like rote formats that we follow and we fit our stuff into it. And, you know, there might be minor adjustments if we've got a particularly weird product or a particularly weird audience. But generally speaking, we don't sit down and think from first principles about like, who is the learner and like what may be the best educational approach from them and how is that reflected in the written text. So yeah, I can't remember exactly why I went on that ramble. I think it's because you just mentioned short videos. But yeah, that was a thought I had. You mentioned accessibility. Sorry, Matthew. You mentioned accessibility, and that was one thing I did actually want to mention because this was a completely novel idea for me in this book. Obviously, like we talk a lot in the industry at large about the importance of inclusion and diversity, and about, you know, making sure that everyone is able to access our materials and access our programs and access our communities. There is a learning theory that explains why this is important, which was, I can't remember which one it's called. It's in chapter 8. I can't remember what the name of the learning theory is, but social cultural or something. But basically, and this also explains developer communities as a whole, which, again, totally my jam. I love that. Which, where it's coming from is the idea that for professions and, like, you know, a lot of bodies of like subjects that you learn where you are kind of entering a community by learning it, like you're becoming a professional in that space. You enter into a community of practice, which is a term we've discussed before. You enter into a community of practice, people who do it, but that there's a very close link there. And I think actually the author makes a complete like equivalence between like the accumulation of knowledge and the accumulation of identity, and how important your assimilation of the identity is for you learning that stuff and you assuming that knowledge. And like that is like, the chapter goes on to explain about, you know, like, this is why it's really important to, you know, make sure that our programs are inclusive and that everyone can come into them, because if people aren't able to assume the identity, like there is literally negative learning outcomes because of this learning theory. And so that was a really, again, just in terms of like explaining a thing that we do all the time. Obviously we have intuitive reasons why this is good. We have moral reasons why this is a good thing to do. But seeing it approached from the learning side's perspective was again, very new to me, and was very interesting.
Thanks for bringing that up. I actually had a moment to look it up. So it's on page 216, social cultural theory. Super fascinating. And as you said, it's putting those thoughts to words, words to see. I'm going to mix that myself up constantly. That explains why it is that these things that feel intuitive now we have that scientific backed research for it. You also mentioned, communities of practice, which is something I'm very passionate about as well. And how, you know, again, the book covers this, of these different like types of pedagogic practices that we bring in, things like collaborative learning, cooperative learning, blended learning, MOOCs are mentioned. What are MOOCs again? Sorry, I keep forgetting the acronym.
Massively online something courses, like the free online universities that are like MOOC things, Coursera, edX, yeah.
And that these are covered there and explained why we do them and how we do them is so invigorating.
Yeah. Yeah, and there's also some, like, you know, we've been talking very theoretically, and, you know, we've done some practical stuff. The back end of the book has some, like, really fascinating, I guess, like, practical material. Like, in particular, there's a whole section about what data to gather from IDEs to, know, like, to check the progress of learners, which, like, should just straight away be integrated into like every online sandbox and docs portal, right? Like there's lots of because again, like this is a book for researchers. These aren't just free thinkers. They're running experiments, they're doing studies, like they need data, they need to test these hypotheses. And so this book does like a lot of that. So if you're the sort of person who's like, oh, I'm gonna, you know, A/B test this piece of content, like read the chapter on study design, read the chapter on what data to gather. It's there as well. Also, 2 great chapters on how to do statistics for results properly, which definitely is valuable.
So, Joe, I think that it would be great if everyone involved in some form of developer education read at least part of this book. But let's be realistic. We're busy. It's an intimidating looking book.
It's expensive.
It's expensive. Other than the Programmer's Brain from Felina Hermans, which you've already mentioned, and the Raspberry Pi quick guides.
Yeah.
You know, there's also out of Raspberry Pi, there's Jane Waite's research, and there's Papers We Love Education Edition, which you're involved in. What are some of the resources I'm trying to ask, you know, that you would recommend people look at if they think this book looks a bit too much to start with?
Yeah, so I guess first thing I would say is just on this book, in terms of accessibility of this book, if you have a academic login of any form for any reason, whether because you're an ex-student or because there's a student in your life, you can download chapters of this book for free from the Cambridge website. So it's possible to get hold of this book without having to buy a huge thing. The Raspberry Pi. So Raspberry Pi is two entities. It is the company that builds and sells the computers, and it's the Raspberry Pi Foundation, whose mission is broadly to further the aims of computing education. The Raspberry Pi Foundation does loads of really good material. As I said, the pedagogy quick reads. They also put out larger books that are free. So they put out the Big Book of Computing Pedagogy. So, I mentioned those different techniques that teachers use that you can just pick up and apply. That is a book explaining all of them. You mentioned Jane Waite. Jane Waite what is a researcher of the Raspberry Pi Foundation. Jane Waite did a summary report for educators where her and a co-author looked at 150 computing science education papers and distilled the findings into one report that teachers can pick up and immediately go and say, I want to do this, this, and this. And you can do the same. And that's for free again online. So Raspberry Pi Foundation, those stuff. They also do computing education research seminars every Tuesday that are free to attend. You can sign up for those. Felina Herman's book is really great for the cognitive chapter. If you're interested in what we've been talking about, the long-term, short-term memory, Felina Herman's book is basically just you can just buy that. And again, the great thing about buying a book by a researcher is it's probably the book that is for sale is probably not the first time they've explored those ideas. Go look up any of these researchers. Go look up the chapter list for this book online. If any of this is interesting, look up the author, find their Google Scholar, and chances are they wrote that chapter because they wrote a paper that's almost the exact same content, right? So you can find these papers that cover these ideas. And that is, I guess, the main thing I would leave it on is this is an academic book that's giving a broad overview of a research field. All these works are published. They're freely accessible in a lot of places. A lot of them are open published. There's a collection of computer science education conferences, which are ITSE, SIGSE, and a bunch, I can't remember. But if you go to the Papers We Love Education README, there is a list of the conferences we draw from. Papers We Love Education is a reading group for computer science education papers. Come and join us. But we also link to a bunch of interesting papers in there and the journals we get them from. So that's a really good place to start, just digging in. And the way academic journals work is they'll hold a conference every year, much like we do. We hold conferences, and people submit their papers to the conferences, and then they go and present them in person. But that means that if you just want to know what's happening in computer science education, just go look up the proceedings for the current year's conference, and there'll be a big listing of all the papers, and you can just dabble and poke through and see what researchers are talking about this year.
And it's worth saying as well that both Felina and Jane had talks at DevRelCon deep dives last year, if you want to find those on developerrelations.com. Well, Joe, Ramon, I found this fascinating, and it's something I really wanted to dive more into. And I have to say that precisely this kind of crossover of learning from another area, bringing it into developer relations, is exactly what interested me in this book club in the first place. So thank you, Joe, for bringing this book to us. Ramon, any last thoughts?
No, this has been absolutely fascinating. I said this is a topic that I keep coming back to, in part thanks to Joe. Thank you so much. Bringing me back and getting that excitement out of me. So I'm super thankful. And, it's like you said, it's having these crisscrossing areas come back into DevRel and talking about them that make this podcast so valuable to me. And I hope for others as well. So thank you both. Joe, if people want to keep in touch or follow along what you're doing, what's the best way for them to do so?
Yeah, good question. I am Joe Nash at Hackaderm on Mastodon. I do a couple of media things on the interwebs about computer science education in particular that I would recommend. The last Thursday of every month, I run Papers We Love Education, which, as I said, is a reading club for academic computer science papers. We often have the authors come to talk about their papers. So I'd recommend coming along to that. You can find more about that on GitHub at the Papers We Love organization /edu. And I said I work on an educational game called Twilio Quest, but I think the most relevant thing for that is the second Tuesday of every month, me and the Twilio Quest developer Ryan Kubik, play other educational video games and discuss how those games are teaching and communicating their concepts and what we can learn from that as game designers and educators. So that is called Press X to Learn, and that would probably be the other thing I would recommend. How
far back do you go? Because you're making me think of things on the BBC Master System from when I was a kid, like Granny's Garden, and I'd love to see you tackling some of those 8-bit games.
We were going to have one of the devs who worked on oh my god, what's the really old American like frontier game?
Oh,
Pilgrim's Trail. Yeah. We were going to have one of the devs who worked on that come on, but unfortunately our contact left the company. But yeah, we go back pretty far. We've done a lot of Zachtronics. We've done like things like Code Combat. We've done a lot.
Great. That sounds superb. Well, thank you again, Joe. We'll see you around.
Thank you so much.